Hello students, today we will study one of the application of Euclid's division lemma. So for that, let us take one of the example, that is of example 2. This is the topic of standard 10, chapter number 1, real numbers. So what is the question? Right? The question is, so that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1, where q is some integer. So in the question we have, there is a word used, is that the positive integers, and the positive integers, if we note down, we get the numbers 1 2 3 4 5 6 7 8 9 up to infinite, right? So we have to show that each these of numbers are either in the form of 2q or in the form of 2q plus 1. If we select any positive even integer, then it will be in the form of 2q, and if we select any positive odd integer, then it must be in the form of 2q plus 1. That we have to show. To do that, let us take a number a. What is a? A is a positive integer, right? A may be 1, 2, 3, 4, 5, 6, 7, 8, 9, any value. A is any positive integer, and let take another number b, right? So what is the value of b? B we can take as a 2. Why 2? Because we have to show that even positive integers are in the form of 2q and odd integers are in the form of 2q plus 1. So let's take the value of a from a as a positive integer. The value of b is equals to 2. Then what will be the value of r? Now we know that the relation between r and b is r is either greater than or equal to 0, or it must be less than of b. So here by putting the value of b is equals to 2, what we will get the relation? 0 less than equal to r less than 2. That means the value of r, we can take one of the value of r, it may be 0, or value of r may be 1, right? Because we cannot take 2, because we have to take the value less than 2. Why? Because 2 b is 2. We can take 0 because the relation is less than or equal to. So we can take one value as 0 and another value of r as a 1. So only two values of r is possible. When we take a as a positive integer, b is equals to 2, then r has a r have maybe two values, r equal to 0 or r equal to 1. So now by using the Euclid's division lemma, we can write down this relation that a is equals to, actually the relation is a is equals to bq plus r. Now putting the value of b, we get a is equals to 2q plus r. So one time we will take r is equals to 0, and one time we have to take r is equals to 1. So according to the Euclid's division lemma, a is equals to 2q plus 0, or a is equals to 2q plus 1. 2q plus 0 we can write down it as 2q. So the value of a is either of 2q or in the form of 2q plus 1. And what we have take as a? We take a as the positive integers. So here you can see that all positive integers we can represent either in the form of 2q or in the form of 2q plus 1. Okay, so this is all about the solution of this question. Now let us understand how this works, how this formulas works. Okay, so for this a is equals to 2q, let us consider a positive integer a is equals to 6. So how we can represent 6? See, we can represent 6 as 2 into 3, right? 2 multiplied by 3 is equals to 6. So what is this 3? 3 is a q, and in the question we have given that we can take any positive integer. So 3, the value of q is 3 here, and this is 2. So this is a form of 2q. Yes, this is a form of 2q. So what we will take a is 6, and 6 is which kind of number? Is an even number. So even number 6 we can represent as in the form of 2q, right? So even number we can represent as a 2q. Take one other example. Let's take a is equals to 38. So we can write down 38 as 2 multiplied by 90. What is 90? 90 is a q. So this is a kind of form 2q. Yes, 38 is an even number, and we can represent 38 as in the form of 2q. Right? One more example, a is equals to 216. So we can write down 216 as 2 multiplied by 108. So what is 108? 108 is a kind of integer q. So again it is in the form of 2q. Again we write down this integer in the form of 2q, and 216 is an even number. So this is in the form of 2q. So all the even numbers, even positive integers, we can write down in the form of 2q. Now let us take the example of odd number. Let's take a as a 9. So 9, how we can write down it as 2 multiplied by 4 plus 1. 4 to 8 plus 1. So total is 9. So this 4 is what? 4 is a q. Q is some integer. So we can write down this 9 as in the form of 2q plus 1. Right? What is 9? 9 is an odd number, and we write down it as in the form of 2q plus 1. Take one other example. Let's take a is equals to 57. We can write down 57 as 2 into 28 plus 1, because 28 2s are 56 plus 1, 57. What is 28? 28 is again q. Q is some integer. 57 is an odd number. We represent 57 as 2q plus 1 form. Right? Let's take one another example. That is 307. We can write down 307 as 2 into 153 plus 1. What is 153? 53 is a value of q. That is one some integer. 307 is an odd number. We can write down this odd number in the form of 2q plus 1. So in this way, we can represent any positive integers either in the form, if it is an even number, we can write down it as in the form of 2q, and if it is an odd number, we can write down it in the form of 2q plus 1. Okay? Okay, let us take one more sum, that is of exercise 1.1, question number 2. What is the question? Question is, we have to show that all the positive odd integers are in the form of either 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. So we have to show that the positive odd integers. So what are the positive odd integers? Positive odd integers are 1, 3, 5, 7, 9, 11 up to infinite, but only odd integers. Now we have to represent all these numbers are either in the form of this or this or this. Okay? So let's take a be any positive integer. Positive integer. It may be odd or even. Let's take a number that may be a odd or even number. Right? So we have take a as a general positive integer, and the value of b, let's take, is equals to 6, because all these are 6. So according to the Euclid's division lemma, we can write down a is equals to bq plus r, and the value of b is 6. So a is equals to 6q plus r. And what is the value of r? R is 0 less than equal to r less than 6. B, here we have to take as a b, and the value of b is 6. So the value of r is maybe 0 or 1 or 2 or 3 or 4 or 5. 0 to 5, r may contain value from 0 to 5. It cannot take the value 6, because r we have to take less than 6. So r here we have to take as 0, 1, 2, 3, 4, 5 and 6. So let's take one by one value of r and make the Euclid's division lemma. So what kind of equation we get here is, first of all we will take the value of r is equals to 0. So this lemma is becomes as a is equals to 6 cube plus 0. I have not written down it as, because the addition of 0 is gives the value 6 cube. Now let's take r is equals to 1. So we will get this equation a is equals to 6 cube plus 1. Now the value of r is 2. Then we can write down a is equals to 6 cube plus 2. Notice that both the numbers have 2 as a common factor. So we can write down 2 as a common factor. What will remain? 3 cube plus 1 in the bracket. Now consider the value of r is equals to 3. So this lemma becomes a is equals to 6 cube plus 3. Now take the value of r is equals to 4. So this equation becomes a is equals to 6 cube plus 4. Again there is 2 is a common. By taking 2 is a common, 3 cube plus 2 will remain in the bracket. Now the last value of r that we have to consider is 5. So we can write down a is equals to 6 cube plus 5. Okay. Now what is the question? Question is, we have to show that all the positive odd integers. We can show that this thing in two ways. One way is, see, notice that all these integers is in the form of 6q, 2 in the bracket, 3q plus 1, and this is 2 in the bracket, 3q plus 2. So if we take these three number 6q, 6q plus 4 and 6q plus 2, all these integers are divisible by 2. We can divide this by 2, we can divide this by 2, and we can divide this number by 2. And remember one thing, if there is any odd number is there, we cannot divide it by 2. Suppose 5. Can we divide 5 with 2? No. Let's take 9. Can we divide 9 with 2? No. So if we take this number as a positive odd integer, then it is divisible by 2. So we cannot consider this value 6q as a positive odd integer. This may be positive even integer. In the same way, this number is also divisible by 2 and this number is also divisible by 2. So out of 6 possibilities, first, second, third, fourth, fifth and sixth, out of these 6 possibilities, these 3 possibilities are divisible by 2. So these 3 possibilities cannot represent the odd integers. Now these 3 possibilities remain, right? So these 3 possibilities, now we can say that these 3 possibilities of A represent positive odd integers. So any positive odd integers is either in the form of 6q plus 1 or in the form of 6q plus 3 or in the form of 6q plus 5. And notice that out of these 3 number, any number is not divisible by 2, because here we cannot take 2 as a common, here also we cannot take 2 as a common, and here also we cannot take 2 as a common. So 2 is not a common factor for all these 3 possibilities. While these 3 possibilities, 2 is a common factor. So these 3 numbers 6q, 6q plus 2 and 6q plus 4 represent the even positive integers, and these 3 possibilities represent the positive odd integers, right? Let's take some example to understand it, right? Let's suppose we want to represent first number. So we can write down 1 is equals to 6 into 0 plus 1. Yes, because 6 into 0 is 0 and plus 1 in the remaining. So 1 is equals to 1, right? So we can write down 1 first positive odd integer in the form of 6q plus 1. 6q plus 1. What is the q? Q is 0. And in the question given that q is some integer. So q is 0 here. Now we represent this 3. We can represent this 3 is 6 into 0 plus 3. Again this is in the form of 6q plus 3. Now we will represent 5. How we can represent 5? 6 into 0 plus 5. So this is in the form of 6q plus 5. Now we will represent 7. How we can represent 7? 6 into 1 plus 1. In this case, what is q? Q is 1. It is again an integer. So this 7 we represent in the form of 6q plus 1, this form. Now 9, we can write down 9 is equals to 6 into 1 plus 3. Again this is 9 is an odd integer and it is in the form of 6q plus 3. Now take 11, we can write down 6 into 1 plus 5, 11. So 11 is in the form of 6q plus 5. In the same way, you can take any positive odd integer and you can check that it is either in the form of this or this or this. Right? So in this way, we can solve this type of question using Euclid's division lemma. Okay? So this is all about this lecture. Okay? Thank you.